Hello everyone. Previously, we learned two annotation methods for columns. In this lesson, we'll study the detailing of reinforcement inside columns. Today, we'll first look at the longitudinal reinforcement splicing detailing and stirrup confinement zones. The longitudinal reinforcement in frame columns can be connected using lap splices, mechanical splices, or welded splices. For longitudinal reinforcement in frame columns, note the following. 1. Adjacent splices must be staggered, and within the same splicing region, the percentage of spliced bars should not exceed 50%. 2. For axially loaded or slightly eccentrically loaded columns under tension, lap splices shall not be used. 3. For longitudinal bars with a diameter greater than 25 mm, lap splicing is not recommended. As shown in the figure, HN refers to the clear height of the column. HC is the longer dimension of the column cross-section, or diameter for circular columns. D is the diameter of longitudinal bars, and LLE is the seismic lap splice length for longitudinal tension reinforcement. Fixity is both a structural restraint condition and a method of reinforcing bar splicing. In this condition, the connected parts have no relative displacement or rotation. Under external loads, the two parts act as a single unit. This location is referred to as fixity zone. For example, a column or wall fixed to its foundation. The foundation surface at the junction of foundation and column is the fixity zone of the column or wall. Superstructure fixed at the basement roof makes the basement the fixity zone of the upper structure. As shown in the figure, for buildings with basements, this shows the connection detailing of longitudinal reinforcement in basement frame columns. This figure illustrates the detailing requirements for columns starting from walls or beams. For such columns, beams must be provided in the out-of-plane direction to balance the moments at the column base. When the column width exceeds the beam width, provide horizontal haunches to the beam. The following figures show the specific detailing requirements when the number or diameter of longitudinal rebars differs between columns in adjacent floors. Figure 1, upper column has more rebars. Figure 2, upper column has larger diameter rebars. Figure 3, lower column has more rebars. Figure 4, lower column has larger diameter rebars. Now, let's look at stirrup confinement zones. This figure shows confinement zones for frame columns, wall-supported columns, and beam-supported columns. All these types share the same requirements. QZ fixity zone is at the wall top surface, and LZ fixity zone is at the beam top surface. This figure illustrates the requirements for stirrup confinement zones in basement frame columns. As shown in the figure, when a rigid ground floor is used in the building, stirrups in columns shall be closely spaced within 500 mm above and below the rigid floor level. That's all for today's lesson. See you next time.